Well, good afternoon, everybody, and welcome along to DBA Fundamentals Down Under, the very first session for 2018. My name's Warwick Rudd, and once again, I'll be your host for the year with our regular sessions on the second Tuesday of every month. Now, kicking off 2018, we do have the privilege of having Kimberly Tripp from SQL Skills here talking to us about statement execution and the plan cache. Now, I will hand over to Kimberly very shortly, but I do have some housekeeping to run through before handing over and starting the session. First off, we just need to say a big thank you to our sponsors, SentryOne. Without those sponsors, it would make it difficult for us to have this session running on a regular basis for you. If you don't already use SentryOne's tools or know about SentryOne, make sure that you go to their website. They have some fantastic articles, videos, and downloads for you that can assist in your learning and assist you in your SQL Server environments. Just to remind you all, this session is being recorded and will be made available on the DBA Fundamentals archive site in a few days' time, so that you're able to come back and review this session at any point in time. Lastly, before I hand over, just make sure that you do stay involved with PASS. There are many ways that you can do that. Like this virtual chapter, there are many other virtual chapters covering a range of technologies and topics, but there's also local user groups, SQL Saturday events, and of course, there's the PASS Summit, which happened in October last year. So with that, I'll hand over to Kimberly and we'll start this month's session.
Well, thank you very much, and thank you for joining us. I guess it's the middle of the day for you. It's early evening for me. Hopefully, I'll keep everybody interested in this. I am going to show one of my monitors here. I have multiple monitors, so there we go. Okay. All right, and let me know if you don't see that, but that should be showing my slide deck. And we're going to be talking about statement execution and the plan cache. Part of the reason that I like this session, is it showing or no?
No, it was showing the first slide, but then it disappeared. Now we're back.
Okay, perfect. All right, so I started to hear you say something, so I thought, it's not showing yet. So this is a topic that I absolutely love. It's one of my favorites because I think it's an area of SQL Server that a lot of folks don't really kind of know why SQL Server is doing what it's doing. And sometimes it's not the most intuitive of products, I'll have to admit. And over the years, this is one of the areas that I've seen be very problematic in terms of caching and cache reuse. So what I'm going to talk about here is how statements are executed, the different methods, and how they affect cache, and whether or not they can be reused, and what the pros and cons are for the different approaches. I'll also lead a little bit into stored procedures. Fundamentally, that's really what I would rather people use, but you might have a lot of reasons why you can't go that direction. Unfortunately, though, if you're doing things through ad hoc statements, which is a very common strategy that people are using through ORMs linked to SQL, you can have some other problems. So that's what we're really going to debate, is the different methods for executing statements, the pros and cons, and possibly some different alternatives if we can. I have a couple of quick housekeeping slides as well. I will make them as painless as possible. I am a member of a fantastic team. I love our team, and many of you probably are aware of us either on Twitter or our blogs, so I'll kind of leave that. I will give all of these slides so that you can put them on your website as well, so you'll have all these links and you'll be able to click through. We do online training through Pluralsight. That's recorded training that you can take and watch. We have instructor-led training in the US, the UK, Ireland. This year we're actually in London, but not Ireland. And we have been to Australia, but it's been a couple of years. I do hope that we'll come back. I actually love Australia. I haven't been to Brisbane though. So, but anyway, I'll continue on. As far as our classes, I've got some lists of the different types of classes. We do in-person classes, and we're actually just starting tomorrow, in fact, about 16 hours from now. So it's probably not the most ideal time of day for you guys, but it's our first live online training course, and it's our immersion event on very large tables. It's really all about partitioning and strategies for dealing with large tables more effectively. And I'm really excited about that. That's a topic people ask me about all the time. And it's probably one of the top 10 or even top 5 that I do consulting wise is partitioning. So it's really a favorite topic of mine. If you want to do a conference, I forgot I put this in here as well. We do not only PASS, our team does PASS, but we also do a conference called SQL Intersection. It's more of a developer-oriented conference. It's great fun. We're back in Orlando this spring. I'll leave that for you guys to look at later. But if you do want to get a Pluralsight code, if you haven't used that in the past, you can email Paul at SQL Skills. He kind of controls the codes, and we have to give them out individually for requested codes, but there's no credit card or anything, and you'll get 30 days access to all, I don't even know what our number is now, but it's over 160 hours of content on Pluralsight. And there are some courses that go into even more depth about some of the topics that we're going to talk about tonight. So at the end of this, where I list all of the resources, I'll tell you the specific courses that some of you might be really interested in. Probably the second one that might be interesting is the Optimizing Stored Procedure Performance course. There are 2 parts to that. It's over 11 hours, which sounds crazy, but you'd be surprised at how many different approaches you can take to optimizing procedural code. So all of that stuff is online on our SQL Skills training site, so you can read about that. And so I want to dive right in. I am planning to spend about 55 minutes to an hour on the technical content. I will watch the chat window, but you can also interrupt me for questions. So that's fine. And I guess I'll just dive right in. We're going to talk about the different ways that statements are executed. We'll talk about how statements can be cached, something called auto-parameterization. Some of you may have heard about that, but I'm going to tell you the pros and cons of it. I'll talk about dynamically constructed strings as well as ad hoc statements. I'll compare and contrast them, and I'll also compare and contrast them with SP execute SQL. That's going to lead me a little bit into stored procedures. I also have some hidden slides. So when you guys get access to the deck, you might want to go back and look at some of the hidden slides that will go into even a little bit more detail on things like literals, variables, and parameters. I usually talk a little bit about that, but I've done some blog posts on that. I've got more content in one of the Pluralsight courses on that. So there's definitely a lot of different directions you can go depending on the topics that you're the most interested in. So let me start with statement execution. Most people think, okay, I'm just going to run a select statement. They all behave the same way all the time. And there's a little bit of truth in that, but there's also some interesting things that can happen depending on exactly how you execute that statement. Now, an ad hoc statement, like you're sitting in Management Studio, you type in a select statement, that is what I would think of as an ad hoc statement. That statement might be able to be auto-parameterized. I've got a whole nother slide where I'll talk about auto-parameterization and spend a couple of minutes on this, so I'll give you a lot more insight. It's not very likely, though. And like I said, when we talk about that, I'll give you a lot more insight into when, why, and how that actually occurs. Now, an ad hoc statement is, like I said, you sitting in Management Studio. Another way that you can get a statement to behave the same way as an ad hoc statement is to build that statement dynamically and execute it with execute. This is very different than SP execute SQL, which is how a lot of people dynamically construct strings and execute them. So in fact, I'm going to put a rectangle around these 2 statements because everything I say about ad hoc or dynamically constructed strings is really going to be synonymous. Everything that you do as a dynamically constructed string is really ultimately turning that statement in to an ad hoc statement. And that statement might be able to be parameterized, cached, and reused. A dynamically constructed string that's executed with exec does not necessarily get recompiled every time. It can be auto-parameterized, cached, and reused. Again, the likelihood is low, But whenever I say a dynamically constructed string, it's really just building that statement and turning it into an ad hoc. So everything I say about ad hoc will apply to statements that have been executed with exec. That is completely separate from everything else on this slide. SP execute SQL, any type of prepared query that you might use through parameter markers or SP prep exec, SQL prepare, SQL execute, anything that is preparing a statement for caching through a client-side application is going to behave the same way as SP execute SQL, and actually, kind of interestingly, the same as a stored procedure. In fact, that's why a lot of these different methods for preparing the statements boast their benefits. Hey, you don't have to write stored procedures. You can just use this SP prep exec, and we'll go ahead and build your cached statement with your parameter markers and then put that in SQL Server's cache and reuse it. And they make that sound like it's a fantastic thing. Don't get me wrong, it can be good, but it's not always good. And this is what I really want to explain. What's the difference between ad hoc and then ultimately the other 3 different methods, which actually there's a whole bunch of sub-methods within each one of these. Those are statement caching methods that are forced. And I promise I'll be very clear on exactly what I mean. So let's start with ad hoc. Just to stress, those behave the same way. And all 3 of these, SP execute SQL, prepared statements, no matter how they're being prepared, and stored procedures, all okay, hold on. Somebody is asking if the audio is connected. Is that everybody? Am I talking to myself? Hopefully you guys are all there. That would be funny. I went a whole hour and a half and nobody was there. Can somebody just chime in and let me know that you can actually hear this?
Okay, Kimberly, I did ask that question, and a lot of people are coming in and saying, yes, they are good with hearing. There's a handful of people that were not. So I did check that before I was going to interrupt.
Oh, so no worries, no worries. I can see the chat window as well. So I just wanted to make sure. I always have this nightmare that I'm going to present for like an hour and a half, get done with a session and be like, what do you guys think? And we got disconnected like 2 minutes into the session. So, okay, well, hopefully everybody's audio will come through now. But let's dive into ad hoc statements and talk about what happens with these ad hoc or dynamic strings, because like I said, those are just going to be turned into an ad hoc statement. Now, the idea of caching a statement, yes, in concept, it's a very good thing, right? It's going to save CPU time. We're not going to have to recompile. We're not going to have a lot of information in the cache because we're just going to have that one cached version of a statement in the cache, which is great. I mean, it sounds fantastic. I can really spin that as a fantastic thing. Now, for statements that can be cached, there is one little tiny negative. It's not a big deal, but when you have an ad hoc statement, like select some columns from a table where member number equals 12 versus select from a table where member number equals 278, whenever they are caching the statements, they will take the data type of the incoming value, not the columns data type. So what ends up happening is if that statement can be cached, it will be cached with that associated data type, and that can lead to a few copies of that plan in the cache, because they'll have one for the tiny int, one for the small int, one for the int, maybe one for a big int. And of course, for a whole number numeric like that, that's not so bad. It can be much more extensive with something like a decimal type. If the column is defined as a decimal 10, 4, for example, you could have, a 5, 2, a 5, 3, a 6, 4. So that could lead to a lot more of the statements in the cache, depending on how the data is input, but it's still going to reuse the plans for any subsequent statement that has the same type as one of those that's in the cache. So it's not a huge problem. And it does sound good because having this plan in cache means we don't have to waste extra CPU. And again, we have this generally reduced footprint in the cache with the, little bit of extra overhead for the different data types. Now, having said that, because this sounds great, right? Most people from a marketing perspective are probably convinced that SQL Server taking my statement, auto parameterizing that literal value into a data type, and then putting that plan in cache with its compiled plan, to a certain extent, that sounds good. However, and this part kind of makes me laugh. I remember the first time that I read about this because I thought, this is kind of cool. SQL Server will automatically cache for me so that I don't have to do that. I don't have to write stored procedures. And then I said, oh, I see that there are some exceptions. So I started reading some of the exceptions. And the very first one is the one that almost made me kind of laugh and say, okay, then what's the point? The only types of statements that can be cached are statements that only reference a single table. If you have a join, if you have a subquery, it cannot be cached. And I want to stress, I'm not even listing all of the rules here. I'm only listing a couple of the rules. But the very first time I read this, I'm like, okay, this is basically useless to me. If the from clause cannot list more than one table, if I cannot have an or, I cannot have an in, you cannot have like, you cannot have any parameters that warrant plan change, or I should say that have any data discrepancies in their distribution, which basically means the only types of statements that can end up going into the cache are statements that are as simple as the one I just talked about a second ago. Something like select a small subset of columns from a table where primary key equals one row value. They have to, in fact, if you actually really read all of the rules for parameterization of your statements and caching, they basically have to be trivial plans, which ends up meaning that the only plans that SQL Server can cache are the simplest and easiest of statements to generate. So anything that takes or is complex to generate cannot be cached and must be evaluated, compiled, and by default, put in cache in its entirety on the first execution. And what ends up happening is you start adding up 1, 2, 3, 4, hundreds of a particular statement just with different literal values in the cache. This is what a lot of people refer to as plan cache bloat. And what SQL Server is starting to do or trying to do is put those literal values into cache so that subsequent executions that have exactly the same value could benefit. But for a lot of you, they don't get executed a second time with exactly the same literal value. Somebody says, select from table where last name is Tripp, select from table where last name is Cahias, select from table where last name is Smith, right? You've got all these different values coming in. And because those statements are not deemed, and the term that Microsoft uses is safe. So because those statements are not deemed safe, SQL Server will not put them in the cache. As a parameterized statement, it will put them into cache with their literal values. And now you'll start bloating the cache. And kind of a good question is, how bloated will the cache be? How much cache can we waste? And I will get to that, especially when I start talking about the solutions to this problem. But let me be really clear on exactly when this happens and how this happens. So we've talked about the limitations. So let's dive into this statement auto parameterization. Everything I've described so far is something called simple parameterization. And parameterization is something you can change at the database level. Now, I want to stress that I generally do not recommend ever changing this. In fact, with all of my customers, I think across our entire SQL Skills team, we've got 3 customers that turn this on, that we've recommended this. So it's pretty uncommon. So I don't want you to dive right in and turn this on. In fact, if you think that this is interesting to you at all, the best thing to do is to really evaluate your server in simple first. And if you start to see a pattern I'm going to describe in a second, then you might consider going to forced. So most of you are going to leave simple, but let me explain forced for a moment. Like I said, it's generally not recommended. But what happens if you change to forced is SQL Server will force more statements to be cached, even those that normally would not have been defined as safe. Now, if you end up having a ton of statements that you have really optimized, you have really good indexes. In fact, you have to have done what we call covering in order for this to really be effective. So let's say you've done a really good job with index tuning. You know the pattern of the queries that are executed against your server really well. You have a limited type of queries, but a very consistent set of queries. So you know your app very well, and your app's usage patterns are pretty consistent. Now, first of all, there's a lot of ifs going on here, and I don't always see environments where the usage patterns are consistent, when you know the usage patterns really well. So I mean, I want to stress that it's already unlikely that most people will meet these criteria. But let's say you think you do have a really consistent pattern, you think you've tuned it really well, you can go and look for what we call plan stability. I've been using this terms for a few years because I wanted to differentiate it from Microsoft's definition of safe. So for a statement to be safe, remember, it's incredibly restrictive, right? What I'm saying here is you've done a lot of tuning such that your statements might not be safe, but their plans are very stable. Now, how do you tell? Notice in the recommendation line on this slide, I say that you can investigate plan stability by using something called query hash and query plan hash. So remember back to the concept I said a second ago. Imagine that I have the statement, select from member where last name is Tripp, select from member where last name is Kahia, select from member where last name is Randal. When those statements are put into the cache, those statements will all resolve to the same query hash. If you then aggregate your cache by query hash and count the number of distinct query plan hashes each query hash has, if they end up only having one across all of the executions, then you know that even though SQL Server did not find that statement to be safe and parameterize it for you, that statement is in fact stable. And if you were to force it, it would be okay, because even across the 20, 30, 400 executions, they all have the same query plan hash. But you can only see this if you look and analyze the cache while you're in simple. Because if you switch to forced, it's just going to force them, and you're not going to know if they would have had the same plan had they not been forced. Now, this sounds a little bit intense. I do have some scripts, and I have a lot more on this in one of my Pluralsight courses, but I will show you a little bit about what I'm talking about. Okay, so this is something, though, that I would never, ever, ever recommend turning on unless you have done a really good job analyzing your query hashes across that database over ideally an entire business cycle. Because, you know, if you look at the cache over the course of a day, maybe things look pretty stable because that day's activity happened to be fairly consistent and stable. But as many of you know, throughout a business cycle, patterns change, users change. And if you really don't analyze your cache accurately, you could turn on forced parameterization and have a different problem. See, right now, the problem that you're having with simple is that your cache might be bloated with a statement that's in your cache over and over and over again. So yes, you're wasting cache, and yes, that is a problem. However, if you switch to forced, then whoever executes that statement first with whatever parameters that statement has, they will define the plan that gets in the cache. So every subsequent user will use that plan. Some of you may already know what this is, but maybe haven't ever heard of it with respect to statements. This is something called parameter sensitivity problems. And you can have parameter sensitivity problems with any method that forces caching, right? So ad hoc statements by default aren't cached. And the only statements that get cached are those that are incredibly simple and safe, right? The ones that Microsoft is sure are safe. In some environments, you might have a stable enough environment where you can force it, but you want to be very careful and not even consider this until you've really done extensive testing. And in fact, I would argue that even without using forced parameterization, there's really a better way to deal with the safe statements. And that would be to possibly, if you can, change their method of execution. Instead of executing everything through ad hoc, maybe choose a different way of executing. So let me explain. So far, I've really stressed simple, and I really recommend that most of you stay simple. It's incredibly rare that you're going to use forced. Now, if any of you really do end up thinking, I want to check out to see if forced makes sense for me, I would recommend checking out the Pluralsight course and checking out the scripts I'm going to give you guys. And towards the end, I might be able to play around and show you a little bit more on this too with some demos, but there's definitely a ton in the statement execution course. And if any of you guys can't find that section, like you just want to go to that really quickly, you can send me an email. My email was on the first slide, Kimberly at SQL Skills, and it's the American Kimberly, Kimberly, not Ley. So you can always send me an email and say, hey, where is that section? And I'll point you right to it. But really, I just want to stress this because you could really get yourself into more trouble by forcing plans into cache. You'd actually be better off bloating the cache and wasting the cache in simple, in most cases, than setting forced if you really shouldn't do it. Okay, so dynamic strings, just to make sure that everybody's on the same page, a dynamically constructed string is building a statement to then act like an ad hoc statement. They evaluate it, they being Microsoft, and they decide, is it safe or not safe? And if it's safe, they'll auto-parameterize it, put it in the cache, and they'll reuse it just like any other ad hoc statement. Now, if your dynamically constructed string is more complex, like it has joins or it has or it has subqueries, then obviously it's not going to be safe. And therefore, it's recompiled for each execution because it would never be auto-parameterized and cached. But a lot of people say dynamic strings are always recompiled. That's not really true. The more accurate statement is dynamic strings are always turned into an ad hoc statement. Then they're evaluated. Is it safe or not? And it's not likely to be safe. So when it's unsafe, it gets compiled for every execution. The strings can be quite large. You can do some incredibly complicated things. Over the years, I had one project where I had to build incredibly complicated strings, and my strings were actually, the max string I ever built was 320,000 characters. And I was actually shocked at how fast and effective dynamic strings worked. So it certainly wasn't safe. But the point is you can do some cool stuff with dynamic strings, but there is a whole nother tangent around security and SQL injection. So I put some links into the zip of resources I'm going to give you guys into some ways to reduce things like SQL injection, or even to do some more complicated and more interesting things with dynamic strings. So that's just a little tangent. If you're interested, there are some cool things you can do, and I've got some extra scripts in the resources I'm giving you guys that might help you maybe learn something about dynamic strings that you didn't know. But I am a big fan of these. You just have to be very cautious with what can possibly be passed into them, but there are ways to restrict it. So dynamic strings, in my opinion, are not something to be totally avoided. They just are something you have to be careful with. Now, SP execute SQL, a lot of people say, use this instead of a dynamically constructed string. And while there are similarities to these two, there are also some big differences. See, a dynamically constructed string executed with exec becomes an ad hoc statement. If you instead build that statement, pass it to SP execute SQL, you are going to be doing something called forced parameterization. So to make this make sense, I want to actually show you this. So I'm going to go into my demo now. Now, my demos can be completely reproduced if you guys want. I have a sample database that I use called Credit, and you'll have all of these scripts. I never put a backup of the sample databases into the zip because it would make the zips huge. But I do put the link, which is what I've highlighted here, into the scripts themselves. So you can download that database and reinstall it on your machine, or I should say restore it on your machine. The only script you'll have to modify is the setup script. And I put a bunch of notes in there to let you know that it's a compressed backup. You can actually restore that to even 2017, actually. You just can't go to 2005 or 2000. If you, I can't imagine that you do, but if you wanted to play around with the older versions because you still have a 2005 server out there and you want to try out some of what I'm talking about, there is a 2000 backup that you guys can use on 2000 or 2005 or even 2008 or R2. But I have a 2008 backup that you guys can restore all the way up to really 2017 now. The things you'll have to change, though, are your paths, right? I don't know where you're going to put the backup. I don't know the name of your server. Do you use named instances? Do you just use a local instance? I don't know what directory structures you're using. So this script, you'll notice the gray highlighted lines, it's a SQL CMD script. So I went up here and I chose SQL CMD mode, which is what highlighted those lines in gray. It's those gray lines that you'll need to change. And I've got some other commented out, maybe versions that maybe you'll use instead for some of the pathing, depending on what version you want to install to. I'm going to throw this on 2014. That's one of the most common versions I see these days. A lot more folks have 2016. The behavior of what I'm showing you right now is exactly the same across really all of these versions. They have not changed the amount of cache or the caching strategy really since 2005 SP2. So this behavior will be the same across all of these. But all of the paths are set up for me, so I should be able to execute, restore credit. So I have a nice clean version of credit. And then I'm going to go to my first script, and I just numbered them 00 for setup, 01 for dynamic. And then I've got these other extra ones, and we'll see how far we get into all of these. But I'm including them so you can play around with some of the stuff. Now, the default behavior that I'm going to show you, as I mentioned, is where SQL Server puts the statement into cache on the first execution. When I talk about how to fix some of these problems, I am going to tell you to turn on a server-wide option called Optimize for Ad Hoc Workloads. I absolutely, totally, 100% recommend this all the time, if that wasn't clear. Now, it has some negatives, don't get me wrong, but I'm also going to recommend something that will help you with those negatives. So there's really two things I'm going to want you to do, and I'll bring it all together after I explain plan, cache, bloat. So give me a few minutes. I want to make sure that I've got the default settings, however, correctly. And sure enough, on this machine, I usually do have this turned off for my demos. So you can see the value in use is 0. So I don't need to change it. But if you need to change it, of course, in a test environment only, you put the name of the option. I'm going to turn it off and then reconfigure, but I don't need to do that. And by the way, this is enough. You only need the number of characters that make the name of the option unique. And that's kind of a cool trick. But continuing on, I'm just going to go to my credit database and I'm going to go and turn statistics IO on. And then I will go ahead and I'll do an update so that I have a very highly selective row for last name. And then I will show you that I'm building an index on last name. And I promise you there are no other rows, you'll find out in a moment, with a value of Tripp. So we'll be able to find that row very efficiently with our index. So I'll create that index. Now, this is not necessarily the best indexing strategy out there. Actually, I do have a new course on Pluralsight on indexing if you're interested. But for this particular example, this index does work for me. And I am going to show you what indexes my table has. I'm just using a slightly modified version of SP Help Index. It's very similar in the index definition, the description of the keys, and the name, but then all the other stuff is stuff that I added. The index ID, I always put 1 and higher so I can tell if there's a clustered index right away, whether or not the indexes are disabled. And then I put a few other interesting things like, are there any included columns or filters, and what's in the tree structure. And if you're not really aware of index internals, I do cover that in the Pluralsight course. I'm not trying to push the Pluralsight course on you. I only have so much time. So if you really want to get into more on that, there are some good resources out there. But you can see that I have the index that I just created, member last name, and then I'll start running some queries. But the way that I'm going to show you what's going on with the cache is I'm going to use a join, really a cross apply with the DMVs, the dynamic management views. They came out in 2005. They're fantastic. And the one that has the query hash and the query plan hash is DM exec query stats. So that's an incredibly useful DMV. But to make that DMV efficient, they don't put the statement text or the query plan in it. So you end up having to cross apply with other DMVs to see the statement and to see the plan. Now, since some of you might have a lot more stuff in your cache, I created a very simple kind of wrapper procedure here so I can pass in a string and then grab the information from cache for just that string. Now, again, since this is a test environment, I can clear all of my cache so that, it doesn't have to wade through a lot more results and be a little bit faster. I can turn statistics IO and statistics time on. I can also go up here and turn on the graphical execution plan. So now I can get a little bit more insight, and I'll show you some of these things as I start to execute some statements. So we're going to start with an ad hoc statement that is, in fact, very simple and will end up being safe, which then means it will be parameterized. So I'll go ahead and I'll say select from member where member number 258. I run it. I see my result. If I go to the execution plan window, you can see that there's a parameter here. And hopefully everybody can see that in the select from member where member number equals @1. Just because there's a parameter there, that does not mean that it was parameterized and cached. All of your statements get parameterized. Whether or not they're cached depends on whether or not it's safe. If it's safe, it will get cached and reused. But just because it shows a parameter here does not mean that you are reusing the plan. So this is not enough, right? I can run this one, execute, and there's no row. But if I go look at the execution plan window, you can see that parameter again @1. But it turns out this is a totally different statement in the cache. And you can't see that here, right? I'll run another one with 32, right? And again, I see, the one row, The execution plan shows that at 1, but if I go check into my cache for anything that has member in it, of course, since I just cleared my cache, that should be pretty limited for me to just these 3 statements. And sure enough, I see that exact statement with the at 1, but with 3 different data types. So this is that little tiny bit of what we call prepared plan cache bloat. It's not that big of a deal. If I keep putting in different values, right? If I put in, 245, well, 345, that's fine. Well, I can't highlight. There we go. And I run it again. And I go look at quick check on cache, then you can see I just executed another small int because tiny int only goes up to 255. So I have an execution count of 2. So now I'm starting to get some insight that it is getting reused because these statements are exactly that. Very simple, very safe. Now, if I were able to build my statements in the client, my preference would always be to strongly type the literal. This is a better way. What I've highlighted here, if I say convert to an int, convert to an int, convert to an int, and I run those 3 statements, the beauty of this, I mean, again, that middle one's not returning any values. The beauty of this is since I've strongly typed it, the nice thing here is I only have 1 plan in the cache that got reused 3 times. I mean, this would be a more efficient way of doing this, but of course it requires you to be able to interact with the application and change the way that the dynamic statement or the statement itself is being generated. If it's in your code that you're building and executing with exec, you can certainly do that. But if this is an ORM or, some environment that's generating the SQL, then you might not have this ability to kind of force this. So you might end up with a little bit of the bloat that happens because the literals are of different data types. Overall, though, none of this is too bad because the statements are going into the cache and they are getting reused. So all of that sounds great. All of this stuff is deemed safe, it's parameterized, and it gets reused. So now I'll run another statement. Select star from member where last name is Anderson. And I run that statement and I see that there's 385 rows. We can look at the plan. You can see that the plan is not using that index I created. It's doing a table scan, clustered index scan. So if I go over here and I say select star from member where last name equals Anderson, most people look at that and they're like, what? That doesn't look any different. That looks exactly the same. And let me sit on this execution plan window for a second. Do you notice that it shows select star from member where last name equals parameter 1? So you might think that this has been cached, but remember, parameterized doesn't mean safe. It just means that SQL Server parameterized it, then they evaluated it. And this one, it turns out, is not safe. And what's really odd, right? I said to search for the letter or the word Anderson. What's really odd is this statement is in there twice and it looks really strange. Like, what's different about those statements? And I did this very purposely. The only thing that's different, do you guys see this? Is I put 1 extra space in the from clause, line 153, versus 1 space up here. So there's 2 spaces here. And yes, I kid you not, textual matching is this picky. It has to be down to the same spacing, tabs, everything. So if you're building a statement through an ORM, the good news is it's going to be consistent. If this is across 3, 4, 5 applications and you've got different methods for building statements, even if you think they're building the same statement, if they're not building it exactly the same way, you can end up with even more bloat across stupid things like this. Look at this next one, right? Select m.star, where member is M, and then m.last name is Anderson. This looks exactly the same. This one, frustratingly, is not only a different query hash, right? I'll just go back to this really quickly so you can see that, but it actually, or it's not only a different statement, but it's actually even a different query hash. So that's a little bit frustrating. These two, at least, lines 1 and 2, will at least generate the same query hash. But if across the applications they use different aliasing strategies or anything that fundamentally changes the format of that statement, then you might end up even having different query hashes, which is even harder to resolve. So that's a little bit frustrating too. I'll go here and I'll show you just different aliases like M versus T. This one, yet a different query hash. So let me do the quick check on cache. And I've actually got a couple of different procedures. Oh, I didn't create that one yet. I have it in another script and I must have gone back and executed this the last time I was playing with this. But there we go. Now you can see, I want to find all the statements that we're talking about here. There we go. All 4 of them are right there. So you can see that there's 4 different statements. Now, what I've also listed here is, let me scroll. I know I'm scrolling quickly. There we go, to the query hash and query plan hash. So let me make sure that we have the right lines 7 through 10. And then we'll scroll back and get that query hash. There we go. So notice the first 2 have the same query hash, but the third and the fourth have yet a different query hash from those first. Now, it turns out so far, since these are all using the same value, Anderson, they actually all happen to be generating the same plan. So you could reverse engineer, which statements end up using the same plan. And then you could look further at those statements to see if they were just different in terms of aliasing. But there could be a lot of different statements that end up doing a table scan, for example, across this table. So that does not really mean they're the same query hash at all. It's just a coincidence here. And I'm just showing you the frustration that some of you might run into if you end up letting a whole bunch of applications generate statements in different ways. So that's one of the frustrations here. Now, I'll run this with Tripp. And this is exactly the same format of the very first statement. I've only got 1 space between the from and DBO. So some of you might say, okay, that's exactly the same format as that first one that I did with Anderson. So sure enough, if I see that parameter, it probably used the same plan. But some of you might be noticing this is not the same plan. This one is using my index. And sure enough, the reason why is that this statement, even though it is incredibly simple, it only references 1 table, it's not safe. So if I go again and look at my cache for all of the statements with last name, you can end up seeing here, last name of Tripp. And sure enough, so that's line 3. If I go look at the query hash, notice it is the same as the Anderson statement, but now there's a big difference. This statement has a different query plan hash. So if you had executed 10, 15, 30, 100 different last names, it could turn out that you end up having 2 or 3 or 4 different query plan hashes across that one query hash. That tells me that that query hash, its plan is not stable. And since it's not stable, this should not be forced. This statement should have different plans in cache because as I'm supplying different values, the optimal plan varies. So simple really is the best choice for this statement. However, back to this other one, if I can do the conversion, then I'll only have 1 copy of the statement in cache. So that's not so bad. But if I do these statements individually with those literals, I'm going to kind of bloat the cache, but not so badly here because at least this statement is safe. But for everything that is safe, a better choice would be to force SQL Server to cache it using SP execute SQL. So I'm about to show you that. I do have some other examples here just to kind of further prove my point that not only is this statement using equality not safe, but things like are very, very much so, well, actually never safe. In fact, can't even be forced with forced parameterization. So even if you were to force the database to parameterize statements, it still wouldn't parameterize a like. And there are some cases, again, if you know the usage patterns, like you don't allow leading wildcards, and maybe you never allow, fewer than 5 characters before a wildcard. And you know that that's relatively restricting, and you've created good indexes for this. The point is that might actually be something that's stable, but because you have like in the statement, SQL will never deem it as safe. It will never parameterize it. It will never reuse it, even if across 1,000 executions, there's only one plan. But you can, right? If you analyze that statement and you've tuned it, as I've mentioned, and you've got good indexes, then the trick is to change the method of execution. Instead of relying on SQL's overly restrictive rules on putting a plan in cache for things that are in fact stable, you should take that statement, build it dynamically, parameterize it yourself, and then use, like you can see on line 212, strongly typed parameters. So member number, it's no longer, an int and a tiny int and a small int and a big int. It's just an int. So now when I execute this statement with SP execute SQL, the nice thing about this is that is going to go into the cache on the first execution, and I'll end up reusing that. Right? Now I'm passing in member number, so this one is in fact good. In fact, I'll execute this. Now notice I just executed that first one a second time. So now I'm executing this statement essentially 4 times. And the reason why I'm saying that is when we go check on cache for MNO, we will see a count of 4 and only one version of that statement in cache. This allows you to take anything that's stable and not have to rely and worry about SQL Server having to deem it as safe, of which most things aren't. And it allows you to force that statement into cache when it is, in fact, nice and safe and stable. This is the method I would recommend. However, you really don't want to do this with something like the name one that I was executing a minute ago, especially if you can have like leading wildcards, %E%, or I think I even had one of TRI. That one might be selective enough actually. But here I will go with Tripp, Anderson, and %E%. And if you remember, the optimal plan for Anderson and definitely the optimal plan for %E% is going to be a table scan. But if I execute with SP execute SQL and I put Tripp in there first, it's going to figure out the plan for Tripp. And I'll show you if I execute that, the plan for Tripp is to use an index. And you can see it's using that member last name index that I created at the beginning, which right now on my machine probably doesn't even seem like an issue. Like I'll run all 3 of these and it comes back, in a second. So most people wouldn't go, wow, look at how slow that was. And if you go to the execution plan window, you'll see 33, 33, 33, which is kind of misleading because it's kind of implying that they cost the same amount. But if you go back over to the messages window, one of the reasons I turned on the IOs is to show you the first statement only does 4 IOs. The second statement does 700 IOs, and the third statement does 10,000 IOs. Now, on my machine, I haven't told you guys, but I have a pretty beefy machine. I have 64 gig of RAM. I have I think it's 8 terabytes of solid state devices, 4 terabytes of which are NVMe drives, and then the other one's a little bit slower, but it is an SSD. My point, and please don't misunderstand, the machine was, first of all, kind of expensive, but it also weighs 9 freaking pounds, right? So there's my trade-off. It's a fantastic machine for a lot of what I do. My point, though, is your developers and you and me, right? We can get away with writing a lot of crappy code and no one notices because it comes back so quickly. So a lot of people wouldn't even have looked at the IOs necessarily. They might have just executed, it ran fast, they were happy, so they moved on. And the problem is they're missing something pretty important here. As this table gets larger, what's happening is very inefficient and will start to be noticeable on bigger data sets, and especially on bigger servers where you might not be, running with a huge amount more memory than what you're executing. Because I'm the only one on my machine right now, and this table is, a couple hundred meg. So this table is going into cache, staying in cache. Everything I'm doing is really just taking a few hundred milliseconds, right? No big deal at all. So this is something that a lot of people don't notice until they're in production and they're having problems. And here's my point. Okay. A lot of environments choose one or the other. Like they do everything through ad hoc. They hear about plan cache bloat. So then they switch everything to SP execute SQL. And what I want to stress is that neither is perfect all the time. Ad hoc statements are better for statements that really do need different plans because of the different values that you're passing in. SP execute SQL, though, is fantastic when the plan is stable. And through a small amount of testing, you should be able to tell that. So this is kind of an interesting thing to get to know and become a little bit more knowledgeable on. So I want to make sure that we're clear. We've talked about ad hoc statements, which is also true for dynamically constructed strings, versus SP execute SQL, right? SP execute SQL is a forced way of caching, and it really is excellent if that plan is stable even across a bunch of different parameters. Okay, I don't know if you can see kind of where my highlighter is there, but it's the first sub bullet under that third main bullet, right? This really is excellent. It is my favorite way of executing statements. It's much better than ad hoc, but only when the statement is stable. If it's not stable, this can actually be worse than using ad hoc statements. And it turns out that everything I've just described is actually what most people have heard about under just stored procedures, right? Reusing plans are good if the different parameters don't warrant a plan change. But if the optimal plan really needs to vary based on the parameters, then reusing a plan can be a very bad idea. So there's all sorts of tips and tricks on how to do this in stored procedures. What I expect, though, is that your application coders and developers probably don't do those things when they're doing that with SP execute SQL. So my issue is that you have to be really careful that you're not in an environment where they use just one or the other, or they hear about a problem with ad hoc and then just switch everything to SP execute SQL, because while you fix one problem, you're going to introduce another. And this parameter sensitivity problem can actually be worse than the plan cache bloat problem. So let me summarize plan cache bloat. I probably have about 5 minutes to bring this all together. A plan sticks around in the cache for a while, okay? There are some things that can kick your statements out of cache. Some are very obvious, like restarting the server or DBCC free cache, which I showed you guys in my script. I have a section in one of my Pluralsight courses that shows you a whole bunch of ways that might be less intuitive. For example, here's an interesting one. If you guys ever change your server's max memory, it sounds strange, but let's say your max memory is 64 gig and you decide to make it 80 gig or something like that. That clears your entire plan cache. And most people just wouldn't anticipate that and wouldn't expect that. So you have to be careful. Just because some option is what SQL Server calls, effective immediately and dynamic, it doesn't mean it's not going to have any side effects. So be careful. So there's a lot of stuff that could kick plans out of cache. So you can learn a little bit more about that if you're interested. There's things at the server level. There's things at the database level. They've even added in 2016 my mind just totally blanked on a scoped configuration database option that can clear what they call the procedure cache, which is very poorly named because that is in fact the plan cache. So it's really frustrating to me because SQL Server is sometimes not consistent in the way that it states these things. But if a plan does go into cache, subsequent executions, as long as they meet a few criteria, will end up using that plan, whether they should or not. And that's really one of the frustrating things. And there are some weird things that happen around statistics on one of the hidden slides that I have after this. So just as a heads up, check out that slide 17, when you guys get the deck and look through that. But let me summarize how much of your cache can be messed up by this, right? Now, a lot of people call it the procedure cache. I try to be consistent and call it the plan cache because it really is much more than just procedures. It's all of your statement plans. It's all of your cache, right? Your procedure cache, not your buffer pool. But here's the interesting thing. They will steal from the buffer pool for the plan cache. So how much would they steal is kind of the interesting question. And if any of you remember your old 2000 boxes and ever had a situation where it felt like when you restarted that 2000 box, things just ran better. And then occasionally, over the course of the day, it would get slower, but at night you'd schedule a reboot and things would get better again. If any of that sounds familiar, and I bet it does, if any of you used 2000 and had only 4 gig of memory on those boxes, SQL would allow your entire buffer pool to be stolen by your procedure cache, even if your procedure cache was filled with nothing but single-use executions. So you'd end up having to go to disk for everything, slowing your entire environment down. Well, obviously, they started to change that percentage. And as of 2005 SP2 and higher, the number is essentially 75% of your first 4 gig plus 10% of the next 60 gig plus 5% of the memory above that. And I translated that on the right-hand side of the screen. So if your SQL Server has access to, let's say, 8 gig of memory, then 3.5 gig of that could go to the plan cache. Now, some of you are probably going, what kind of SQL Server is she running on that only has 8 gig of memory? How lame is that? Well, how many of you guys are virtualizing? How many of you guys are consolidating and shaving off resources to specific virtual machines? Maybe the server has 512 gig or 256, but the VM only has 8 or 16. You're giving away maybe half of your memory to the plan cache. And that doesn't even include the memory for like the executables and security and permissions and so forth. So you might end up having very little memory for your buffer pool, and you might be filling your plan cache with single-use executions. Select where last name is Tripp, select where last name is Cahias, select where last name is Smith, and all of those are going into the cache and never getting reused. So you're wasting cache with the expectation that someone somewhere might execute the same text again. So how do you fix this? Okay. The first thing I'm going to want you to do to analyze is analyze for bloat. Now, I've got some hidden slides on this, and I've got some blog post resources on this. And I'm kind of pointing you to that because I did this blog post series. In fact, you know what I'm going to do? I am going to, wow. I'm going to bring up, yeah, there we go. I'll bring up a window here and I'll just quickly go to plan cache bloat trip. And you'll see my plan cache ad hoc workloads and clearing the single use cache and my plan cache archives. This is actually the result of the post that talks about how to analyze your cache. And right at the top, I have a query. So you run this query and you check out your server. And then you go to that next post. And this is the result, or these are the results that I got from some clients. And just look at the last column for a second. The percentage of their memory that the percentage of their cache, I should say, that is been used more than once is like nothing. 99% of their cache is been used only once. I don't know why there's bathing suits on here, but anyway. So anyway, oh, probably because you guys are in Brisbane and it's warm there right now. It's certainly not bathing suit weather here. And I'm kidding. It obviously doesn't know about you guys in Brisbane. That was just a joke. I just don't know why it's showing bathing suits. But anyway, 99%, 85, 68. These are real results from clients. These are the percentages of their cache. So out of 8 gig, almost the entire 8 gig had only been touched once. That's really 8 gig that I would much rather be giving to my buffer pool. So back to my slide, right? You can analyze your cache to see exactly how bloated your cache is. And the first thing I'm going to tell you to do is to turn on that server-wide configuration, optimized for ad hoc workloads. But even if some of you already have that on, you still can have bloat. It just takes a little bit longer to get bloated, because what that does is says, don't put the plan in cache until the second execution. But it does put a little tiny stub in the cache. And one of the negatives is that stub is small. So finding that stub in the cache to see if it's been executed already sometimes starts to slow down the more cache you give to your plan cache. So here's what I do. I always do this step: set up a job that regularly monitors the cache and clears part of the cache when it's gotten to a certain size. So let's say I allow up to 16 gig for my SQL Server, which would then allow up to, if we go back to that slide for a quick second here, if it's 4.2 gig, I don't want it to get anywhere near that. So what I might do is check the cache, and if more than a gig is being used for single use plan cache, then I clear my ad hoc plan cache pool. And all of this, how to do this and the code to do this, is in that blog post. That's why I'm referencing that. If you scroll down, I tell you about clearing the entire cache, right, with DBCC free proc cache, which I showed you. But this is what's cool right here at the top. If you want to clear just the SQL plans, you can use DBCC free system cache, and that clears just those. And then you can end up looking at my code at the bottom. And my favorite is really option number 3. I wrote a little stored procedure that you can end up putting into a job. And you can end up, let's say, every half hour, how much of the plan cache is being wasted? Is it greater than, let's say, 1 gig? If so, clear the ad hoc plan cache. And that's this little procedure that you can end up automating and have it run. Let's say I have some clients that run it every half hour, and it might not do anything except every, let's say, 2 hours, right? But I've got some clients that run it every 15 minutes. And even within 15 minutes, they're already above the threshold that they want. So they end up like every 15 minutes clearing, again, not the entire cache. I really want to stress, they end up clearing just the SQL plans which is the ad hoc and prepared plans. It's not your stored procedures. Okay. So this is just clearing the ad hoc statements as well as the SP execute statements. So that is a little bit of a bummer, but the SP execute statement will be cached on the next execution and it will get reused for 15 minutes and you'll suffer a tiny bit of recompilation every 15 minutes, for example, if it's clearing, but at the benefit of, let's say, getting back 3 or 5 or 6 gig on a machine that maybe only has 16 or 32 gig, which actually can be very helpful, especially when all that memory was being wasted by single-use plans. Remember, you're only clearing if the majority of that memory is single-use plans. So you're not clearing it if, you're getting 99% reuse. You're clearing it when you're getting 99% not reused. So I know there's a lot of stuff here. I'm glad it's recorded because you guys can go back and look at this and work through this. If you really wanted to go through all of these individual pieces, you could also check out the Pluralsight course. Ultimately, after you do these two things, turning on the server-wide configuration and set up the job, then I want you to make sure that you've got the right balance. For ad hoc statements, you use those for anything that really does need different plans. And you want to switch anything over to SP Execute SQL so that they have nice, stable plans that are getting reused. But again, having your application developers know how to do this and do this correctly all the time, I think is a little bit challenging. So my personal preference, if you can move the request off of the client and put that code into a procedure and get some really good insight into how to write your stored procedures more effectively, then you get the centralized logic, the code reuse, you can compile plans when they're stable, and you can do all sorts of things when they're not stable. And I've got a ton of tips and tricks for kind of the different patterns that a lot of stored procedures have, because it isn't just one size fits all. So that's my general direction that I recommend. So that is the summary for tonight. I know I went a couple of minutes over. This is just such a great topic. I love this topic, and I think it really does make a difference on how you guys interact with your server. You get to use cache more effectively. You get to have your buffer pool more effective. You put things into cache that really should be in cache. You save CPU by doing it, and you make sure that the things that aren't stable are getting good plans on each execution. So that's really cool. So that's what tonight was about. If you send that email to Paul to get a Pluralsight code, there's 3 courses that go into almost 18 hours of detail about the stuff we talked about tonight. So a huge number of interesting scenarios and tangents and different ways to analyze your cache and the DMVs. And the first one is the optimizing ad hoc statement performance. That one's 7 hours on the stuff we just talked about. So all those tangents that I talked about, analyzing things like query hash and query plan hash, I actually have demos of that in that course. Optimizing stored procedure performance, if you are convinced after watching that stored procedures are the direction you want to go, then I've got all sorts of tips on tricks and all sorts of different ways to deal with recompilation and so forth. And then I didn't even mention this, and I almost hate to mention this at the very end here, but there's some really weird things that happen when your different clients have different session settings. You actually can't reuse plans across certain session settings or across things like resource governor pools. Like, have you ever executed something in Management Studio and it worked one way, and then you went to an application and it worked a different way, and it's terrible. It's really frustrating and hard to troubleshoot. That's what part 2 talks about, is the environmental impact your applications have on caching behaviors and how to dive into the cache and see all of those different, what we call plan cache attributes that each plan has. So that's really interesting. So those are the courses on Pluralsight. The blog posts and the resources that I've referenced, there's some white papers, and I've put all the links in here so that you can find these a little bit more easily. You could do, like I did, the Google Bing search for the plan cache bloat posts, but I've got the links in here as well. And in the presentation that I'm going to give you guys, all the links will be active. So you shouldn't have to type those in or anything. You should be able to find all of this stuff. And then I have one last set of resources. I have another presentation that I did on Past TV. So that one's also available for free. So there's just a ton of stuff out there. You can spend hours on this, and it really is a favorite topic of mine. So what I'm going to do is open up for questions. I haven't seen any or heard any. I'm still hoping you guys are still here. I'll stick around for questions. And then when we're all done, I'll wrap up all these resources and send them off so that within the next couple of days, when the recording is available, you'll also have all of the demo scripts, all of the links I told you about, and the presentation as well. And outside of that, I really appreciate you guys joining us tonight. It's been really fun, and I'm still hoping you're still there. So thank you.
Thank you, Kimberly.
Oh, phew. Okay. I'm telling you, that nightmare is going to come true someday.
Okay, so we have got a couple of quick questions.
Okay.
So first off, did I hear you correctly? Even in stored procedures, only safe statements are cached and reused?
No, in a stored procedure, you are going to cache that plan on the first execution of that stored procedure, no matter what the statements are. So that is a forced caching method. And that's why stored procedures can have problems where, let's say, the first execution is maybe not typical. Subsequent executions are going to get that plan, whether they should have it or not. So they have that same problem that SP execute SQL has, that they are cached on their first execution.
Okay.
Let me add though, because maybe this is a little bit of a tangent there. If you put a statement in exec inside of a stored procedure, then you turn the statement into an ad hoc statement. And that statement may or may not be cached, right? It's cached if it's safe, but it's not cached if it's not safe.
Okay.
No, it's a great question.
With the other details that you'll provide and we'll put up on the website, does that have the quick check on cache stored procedure in those resources?
Yes, it's actually in the second demo script where I start to analyze query hash more. There's the quick check on cache with size, and then the quick check on cache with size and plan. It's just, there's only so much time. But yes, all those procedures are in there. And even some of the stuff on analyzing the cache is even in there. This is also from that blog post. So I also have some things like getting your top 100, grouping them, the free system cache, the SP configure. So if you guys end up opening those scripts, you'll see a lot of the things I talked about, but I just didn't have time to demo everything. But I will bundle up. In fact, I'll show you guys what it's going to look like. I got to pull that over to this window. Why is that not going there? Hold on. There we go. Okay, so you'll have the setup script, the dynamic string execution, analyze query hash. I've got these blog post links to some of the resources that I mentioned. I've got a couple of concepts that people had asked me about in other sessions, the dynamic string execution security problems, so SQL injection, and some of the advanced executions, and then the PowerPoint. So this is what I'm going to bundle up with this session tonight and send this off to you. So yes, you guys will have all that. And if there's something else that maybe I referenced or you thought about and you don't know if there's a resource for it, you can always send me an email too.
Excellent, thank you. Now, you mentioned about parameter sensitivity.
Yes.
Is that the same as parameter sniffing?
Yes. So a lot of people call PSP parameter sensitivity problems or parameter sniffing problems. So yeah, the term is sniffing because we're talking about whether or not SQL Server can sniff the histogram and actually get detailed information about values. But yes, all of these parameter sensitivity problems are exactly the same as parameter sniffing problems. And I kind of use both of those terms, especially when I'm talking about stored procedures. Here, for some reason, I guess was consistently saying parameter sensitivity tonight. So, but yes, they're synonymous.
Now, this next one, I guess it's a bit broad, but is everything that we covered tonight applicable to Azure?
Yes, except the amount of control that you have. And that's a great question. Our main guy on the team is Tim, so I wish he were here. You know what I can do? I can send off an email and see if there's any differences there. But what you really want to know is if ad hoc and SP execute SQL, those will behave exactly the same way. But your ability to clear is going to be different. You are not going to be able to do a DBCC free system cache SQL plans because that is a server-wide setting. So the level of control you're going to have is very limited there. And in fact, I would argue your only options are going to be options I talk about in the online course, which are to either use what we call a templatized plan guide, which is where you can take an unsafe statement and force SQL Server to make it safe by not changing the code, by not changing any of the settings, but instead by creating a database level plan guide. So I'd have to check, because that I know for sure is what I do on some servers. But the question is, are template plan guides available in Azure? And that would be my hope, because that would be the best way to do it. But again, you're just going to be limited on your control. You can always use stored procedures. And that ultimately would be a much, much better way to go in any environment, because then you can control it much more granularly and much more effectively. So I guess the way that I would go here is saying, if you let the application do anything it wants, your ability to control it is going to be different depending on what kind of server you're accessing. But if you force the application to go through a stored procedure, you have ultimate control. And that would be my preference in any environment, including Azure. But as far as SP execute SQL and dynamic strings, they would have to be the same. You just wouldn't be able to fix them the way I've told you, because those are all server options. So that's oh, you know what? They are, oh, I don't know if that's public. So someday there might be a way to control this at the database level. The optimize for ad hoc workloads might become someday a database level option, I think. That's all I'm going to say. Because I'm not sure where that's at.
Actually, I can jump in there. It is actually, yes.
It's in 2017 in Azure, right?
Yes. So Joe Sack put a blog post out last week announcing
Thank God.
the feature, and I should be able to.
I can put that link inside here, because yes, now that you say that I did hear about it last week as well, that it's been released. So phew, and that is in Azure. So there is a way to turn on optimize for ad hoc workloads at the database level.
Yes.
So you have that level of control, but not the clearing. So you still can end up having some issues here. It's a great question. And that's kind of my love-hate with Azure. There's so many cool things you can do. And there's so many things, this is a great week to talking about, not having to deal with CPUs and hardware. you know, the fact that you put something into the cloud and you get those benefits of them being able to change your hardware and you not having to deal with it, sure, that's fantastic. But you do lose some of these levels of control that we have available on the box product. But they are making it better and better. And that is one of the things that they've added to Azure already. Great question.
In sys database scoped configurations,
yes,
we now have the configuration optimize _ for _ add _ hoc _ workloads.
Thank you, Microsoft and its underscores. Awesome. No, that's great, because I knew it was coming and I just couldn't remember what state it was in. Very
good. Well, thank you everybody for joining us. I believe so. There are lots of thank yous, pats on the back.
Awesome.
Thank you very much.
You're welcome,
Kimberly.
guys. Thank you.
And everybody, I look forward to seeing you all same time next month for our next session. And until then, stay safe.
Cheers. Thanks, everybody.
Bye.